In this video, I will discuss the factors affecting the first ionization's energy of elements across a period and going down a group. I will also discuss the anomalous behavior across period 2 and period 3 between group 2 and group 13 elements and between group 15 and group 16 elements. Hey, I'm Teacher Tan. If you like my videos, do remember to click on the subscribe button below so that you won't miss any notifications as I update my channel.
Now we move on to look at the factors affecting variations in first ionization's energy. As across a period, the dominating factor in affecting the first ionization's energy of elements is effective nuclear charge. As across a period, proton number of elements increases. This will cause the effective nuclear charge to increase. And when effective nuclear charge of elements increase, means that attractions between the nucleus and the outermost shell's electrons become stronger. As the attractions between the nucleus and the outermost shell's electrons become stronger, the distance between the nucleus and the outermost shell's electrons will become closer. And this will cause the atomic radii across a period to decrease. When the atomic size becomes smaller, more energy will be needed to remove an electron from an atom. Hence, as across a period, the first ionization's energy of elements will increase. When going down the group, shielding effect becomes the dominating factor in affecting the variations in first ionization's energy of elements. When going down the group, the number of shells filled with electrons increases. This can be seen by increase in the highest principal quantum number of an element. When the number of shells filled with electrons increases, shielding effect is expected to increase as going down a group. This will cause the attraction between the nucleus and the outermost shell's electrons to become weaker, and the distance between the nucleus and the outermost shell's electrons to become further. Hence, atomic radii, when going down the group, is expected to increase. When the atomic radii gets larger, less energy is required to remove one more of electrons from an atom of an element. Hence, when going down the group, the first ionization's energy of an element is expected to decrease. Now we move on to look at the variations in the first ionization's energies across period 2 and period 3. Generally, first ionization's energy of elements increases as across period 2 and period 3. However, there are dips between group 2 and group 13 elements, and also between group 15 and group 16 elements. Why? I will explain the dip between group 2 and group 13 elements first. For this, I use beryllium and boron as the examples. For beryllium, the electronic configuration is 1s2, 2s2. From the electronic configurations, we can see that the 2s subshell of beryllium is fully filled. For boron, the electronic configuration is 1s2, 2s2, and 2p1. The 2p subshell is partially filled. For fully filled 2s subshell, it is more stable than the partially filled 2p subshell. Hence, more energy is required to remove an electron from the more stable fully filled 2s subshell than the less stable partially filled 2p subshell. Furthermore, the 2p subshell is located at higher energy level than the 2s subshell. When the 2p subshell is at higher energy level, it basically means that it is more shielded by the inner shell's electrons compared to 2s subshell. As 2p subshell is located at higher energy level, means that less energy is required to remove one electron from the 2p subshell than remove an electron from the 2s subshell. How about the dip between group 15 and group 16? For this, I use nitrogen and oxygen as the examples. For nitrogen, the electronic configuration is 1s2, 2s2, 2p3. And from the electronic configurations of nitrogen, we can see that the 2p subshell of nitrogen is half-filled. And the electronic configurations of oxygen is 1s2, 2s2, 2p4. By looking at the electronic configurations of oxygen, we can see that the 2p subshell is partially filled. The half-filled 2p subshell of nitrogen is more stable than the partially filled 2p subshell of oxygen. Hence, more energy is required to remove an electron from the 2p subshell of nitrogen than the partially filled 2p subshell of oxygen. Furthermore, pairing out of electrons in one of the 2p orbitals of oxygen also increases the electron-electron repulsion in the 2p subshell of oxygen. Hence, less energy is needed to remove an electron from the 2p subshell of oxygen. Therefore, oxygen has lower first ionization energy than nitrogen.